Insertion sort. What is insertion sort? Insertion sort is a simple comparison-based sorting algorithm that works by taking one element at a time and inserting it into its correct position in a growing sorted list. So insertion sort bale is magkuha siya if iyan tagsa-tagsaon ang kada element starting from the left and then working towards the right until ma-arrange siya from smallest to biggest. It operates much like how we sort playing cards in our hand, where we pick up a new card and place it in the proper order among the cards already arranged. Because of this, insertion sort is easy to understand and is most effective when working with small datasets or data that is already partially sorted. Because of this, insertion sort, kay dali ra siya if effective siya if kanang gagmay ra na array ang ato ang i-arrange or data na or array na partially sorted na kay dili naman maglisod ang insertion sort ug pag-sort ato na array. Now, here are the pros and cons of insertion sort. Pros: it is easy to understand and implement, making it ideal for beginners. As I've said, it works very efficiently on small data sets and performs well when the data is already partially sorted. The algorithm is stable, meaning it preserves the relative order of equal elements and sorts the data in place so it does not require extra memory. Cons: it is inefficient for large data sets because it has a slow average and worst case time complexity. So if dagko na imuhang datasets or imong array, for example, na kay 100 kabuk array, so mag-start mo na siya sa pinaka-left, niya arrange all the way to the right. So madugayan na siya since ang insertion sort iyan ang itag sa tagsa kada array, di bale? As the number of elements increases, the number of comparison and shifts grows significantly. Because of this, insertion sort is generally not suited for sorting large lists compared to faster algorithms like quicksort or merge sorts. So, ang insertion sort kay ideal siya sa mga gagmay na dali ra ma-compare since magsuot siya sa 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, mga ingana lang. And there are other types of sorting methods para sa mga dinagko na kuan mga datasets. Now, how insertion sort works. Insertion sort algorithm begins with the second element in the list, since the first list is already considered sorted. Then it compares this element with the ones before it, and if the value is smaller, the larger elements are shifted one position to the right. This process continues until the elements can be inserted into its correct position, and the same steps are repeated for the remaining elements until the entire list is sorted. So, ayan na ang insertion sort. Okay. Here's an example array. It shows here na kuan. We have 1, 2, 3, 4, 5, 6, 7. 7 elements. And since that array starts at 0, mo atong first element is 0. We have 64, 34, 25, 12, 22, 11, and 90. Now, it said that mag-start ang insertion sort in the second element in the list since the first element is already considered sorted. So, arita mag-start sa index 1. Now, ato na siyang imagine na ibutang nato sa temporary na int. Then, ato i-compare siya sa before niya, which is 64. 64 is larger than 34, so i-move siya dire. Then, balik na tong 34 area. Next is, area na ta sa index 2. Buta na to dire So, temporary. Then, ito yung compare. 64 is larger than 25. Then, putang na ito, are. Kaya mas dako man siya. Ang 34, mas dako pang gyapon sa 25. So, butang gyapon na ito dire. Then, are. Butang na ito, 25. Ibalik na ito sa pinakauna. Next is 12. Butang na ito dire. Is 64 larger than 12? Yes. Butang dire. 34. Yes, gyapon. 25. Yes. Then, butang na ito ang 12. 22. 64 larger than 22? Yes. 34? Yes. 5. 22? Are kay dili naman siya. 12 is smaller than 22. Next is 11. 64. 34. 25. 22. 12. 11. And 90. Ang last is 64 larger than 90 dili. So, stay put na siya. So, nga nara ang pag-arrange sa paggamit sa insertion sort sa array. Nga na yung visualization. Now, na-arrange na siya from smallest to biggest, 11, 12, 22, 25, 34, 64, and 90. Now, naata dire sample code. So, arita sa Google, mag-contact promise tayo. Online compiler lang ta. Into std.h. Now, first, mag-define ta og function na tawagon og insertion sort that takes an array called R and its size called N as arguments. Now, for the outer loop, we start with I equals 1 because the first index at 0 is already considered sorted as default na baya. This loop represents the element we are currently trying to insert into the correct position in the sorted portion of the array. The next is int key equals R. So kani key is the value of the element we want to insert to the second portion. And J is the index of the last element in the sorted portion. So muna siya din na part ang mag-store sa current element lang. Mura katong temp. And for the inner loop, muna ang gamit ani kay mag-shift na ni sa elements. This part. Ang gamit na ni kay, dire dapita. It means the current element is bigger than the element we want to insert. Now, if correct siya, move the area. After na to, ma-compare ang R na to with the key sa kato ang gi-store. If correct gani natin na mas dako, then muni diri na part ang mag-shift sa bigger element one position to the right, making room for the key. So aron katong isod na to sa temporary, ma-move na to siya sa left. After shifting, this is where the element is placed in the sorted portion, keeping it in order. Dito sa main function, we declare an array with sample numbers, size of, So dire mag-declare ta og array with sample numbers para ganiya 64, 34, 25, 12, 22, 11, and 90. Now, int size of r divide by size of array 0. All this does is calculate how many elements are in an array. Size of r gives total bytes of the array. Size r0 gives the size of one element. Now, we print the original array. Loops to the array to the print numbers before sorting, so we can see the difference after sorting. So dire dapita iguro na nato gi-print ang original array na wala pa nakasort. So kanang 64, 34, 25, 12, 22, 11, and 90. Array I. Okay. Next is atong itawag ang void loop nato sa babaw. Katong insertion sort. Na muna ni diri na part ang mag-sort sa array na atong given defined. Ang mag-sort na anang int r o int n. I-pass na siya, meaning the original array in the main is modified directly na. Next is printing the f slash n sorted array. So, ari diri na part is muna niya mag-compare na to sa original array. Ato na i-print ang nakasort na in I equals 0, I less than n, increment print percent %p command array I. Turn 0. Okay, so tiba na. Now, atong i-run. Nag-error. Wait. Ay, mali ang atong nabutang sa array. Wala di ay kuan. Like, open parenthesis. Wala. Wrong gihapon. Dili di parenthesis gamit. Sorry. Kato ding sweetly. Okay, nara. Original array is 64, 34, 25, 12, 22, 11, 90, and then sorted array is kanana. Nakasort siya. Okay. So, mao to siya ang code, sample code na to para sa insertion sort. Now, time and space complexity. Ang insertion sort, in worst and average cases, has a time complexity of O times n to the power of 2 because each element may need to be compared with many others. However, if the list is already sorted, the algorithm only needs to go through the list once, resulting in a best case time complexity of O times n. In terms of space, insertion is very efficient since it works in place and uses only constant memory. So kung unsa ray naa dira nakabutang, mura pod ang magamit na memory sa insertion sort, dili siya mag-need og additional na memory. Now additional sa insertion sort is searching. Now what is searching? Searching is the process of finding a specific value within a list or an array of data. It is commonly used to locate particular information efficiently, and the two most common searching algorithms are linear search and binary search, each using a different method to find the desired value. Now, linear search works by checking each element in the list one by one until the target value is found or the list ends. It can be used on both sorted and unsorted data, but becomes slow and inefficient when dealing with large data sets because it may need to examine every element. So, yung nga na linear. Asa to ang, for example, pwede nga linear o both sorted and unsorted. So, aron lang ta sa sorted, kaya na-sort naman din nato. For example, mag-search ta sa 34. Now, linear works by starting linear list one by one until the target value by checking each element. Oh, iyan tagsa-tagsaon. So, mag-start siya diri sa index 0 dire. Dili man siya mo equal og 34. So, move on siya na next. Dili gyapon mo equal og 34. Move sa next until mo equal siya sa 34. So, muna niya ang kuan. Muna ang pamaagi sa linear searching. Then sa binary search is a fast searching algorithm that only works on sorted lists. So sa sorted list siya mo gamit. It repeatedly divides the list into halves and checks the middle element, allowing it to quickly eliminate half of the remaining data at each step. Because of this method, binary search is much faster than linear search, especially for large datasets. So, ang binary is mag-start siya sa middle element. So, unsa yung middle element dire? O sa atong gipangita, 34 gyapon. Middle element is 3. 3 kay dili man mo equal o 34. Then 34 is greater than 3 man. So, tanan na naa sa left side na automatic na tanggalon niya. So, automatic na tanggalon na sa binary search. Narita. Balik ta then sa middle gyapon. Okay, binary search always starts in the middle. 5 does not equal 34. And 34 is smaller than 5. So, iyang i-remove tanan na sa right side. Then middle na man diri iyan na lang i-compare sa duha of which ang nabilin na mo equal sa iyang gipangita na number which is 34. So naa siya diri sa index 4. Nga na pamaagi o pamangita sa binary search. Next is deletion. Deletion is the process of removing a specific value or element from a list or array. After the element is removed, the remaining elements are shifted to fill the space, which reduces the overall size of the list. So, ang kanang deletion is very simple. Mag-delete ra siya. Now, if gusto na ko i-delete ang 34, delete, then tanan naa sa right side, i-shift na siya, balhin na riya. Balhin na rin. Then matanggal na ang 6. Okay? 5 naman lang ato ang elements. No. 1, 2, 3, 4, 5, 6 day. 6 na lang ato ang elements. Nga na lang ang pamagi sa deletion. The uses of insertion sort. Insertion sort is commonly used for small data sets and partially sorted lists because it performs efficiently in these cases. It is also widely used for educational purposes since its steps are easy to understand and is sometimes applied in embedded systems where simplicity and low memory usage are important. So, ang kanang insertion sorts, good for educational purposes, ano siya, pareha sa karon na magtudlo ra o very basic para na pamaagi na sorting, dali ra man siya i-sample and dali ra siya i-visualize compared sa other sorting methods. It's also applied in systems where simplicity and low memory usage is important since, as I've said ganiha, ang insertion sort dili siya mogamit og large na memory since it involves in the current man, dili na magkuan sa to dili magkuan mag-deal og mga dagko na datasets, di ba? Now, in conclusion, insertion sort is a simple and effective way to arrange values step by step. Searching helps us find specific data within a list, while deletion allows us to remove unwanted data. All of these processes are essential concepts in programming and widely used in many applications. So, mao ra to ang insertion sort with the addition of searching and deletion. Thank you.